Okay, let's look at this limit. The limit is x goes to 0 of x squared times sine of 1 over x. That looks like a tough one because, we can't plug in a 0 here for x because then we get sine of 1 over 0. That doesn't work. So we need another technique for figuring out what this limit is. So let's think about it this way. Let's consider sine of 1 over x. Now, we know that sine has a range between -1 and 1. You're not going to have sine bigger than 1 or sine less than -1. So sine 1 over x has got to be between -1 and 1. That's just the way sine is. So let's think about this. Let's think about x squared sine of 1 over x. Now, how big can this possibly be? Well, it could be x squared times 1. That's how big it could possibly be. So it's going to be less than or equal to that. Well, how small could it be? Well, it could be x squared times -1. In other words, it's going to be between these two numbers. So if sine were as small as it possibly could be, which is -1, you would have this is bigger than -1 times x squared. If sine is as big as it can possibly be 1, then you would have, x squared times 1. The point is, this right here has got to be between -x squared and x squared. Well, okay, so we know how to box this in up here. Okay, now let's think about the limit then. We were talking about this limit here. Let's think about the limit of the left, the negative x squared. Well, the limit of -x squared is going to be 0. That's pretty clear. I mean, this is just a polynomial. So we can figure out that limit just plugging in. Now let's look at the limit of the right-hand part, this x squared. The limit as x goes to 0 of x squared. Well, that's also 0. Now realize that this inside right here is always greater than or equal to this, -x squared. And it's always less than or equal to x squared. So, you can follow these inequalities and see how things line up. This is always less than or equal to this, which is always less than or equal to this. So you've got this limit is 0, and this limit is 0. Well, if both of these limits are 0 and this thing is boxed in between, right? It looks like this thing would be squeezed. Squeeze with me. It looks like this thing would be squeezed in between. In fact, it looks like this limit would have to be the same. It looks like that limit would be 0 because if it's getting squeezed from below with this function, squeezed from above with this one, these are just coming together and pushing this thing to 0. So this is an example of the squeeze theorem, where we found a function that's always less than or equal to the inside here, this one, and we found another function that's always greater than or equal to this one, and these two functions have the same limit. In other words, this function and this function have the same limit. So what we have is, we have this situation where we have h of x less than or equal to f of x less than or equal to, let's say, g of x. Okay? And we notice that the limit of h of x, well, the limit of h of x as x goes to a is equal to the limit as x goes to a of g of x. Therefore, the limit as x goes to a of f of x. And let's say this is equal to L, must be equal to L. Now, let's take a minute and look at what this looks like graphically. Okay, so here is the graph of x squared sine 1 over x, right here. Here's the graph. And I've kind of adjusted the windows so that we could kind of see what the thing is doing. It's going crazy in here, right? Look at that oscillation. It's going crazy. So it's difficult for us to determine anything about the limit. However, look over here. I've got this negative x squared. Let's throw that one in there. Ah, there it is. Look at that. There's negative x squared, and we know that limit is clearly 0 right there. Now let's throw in the x squared. Ah, there it is above. Look at that. So now if I take this one out, you can see, look at that. You can see clearly the negative x squared, the positive x squared, put back in that one, and it fits nicely. So you can see, yeah, this function right here is being squeezed in between the x squared and the negative x squared. Yeah, that's what's happening. So we could zoom out if we want it, change the window settings, but you can see what's going on there with that graph. And this is the idea between the squeeze theorem, that if you can find a function that's always smaller, a function that's always larger, and those two functions have the same limit, then that function in the middle is going to agree. It's going to have the same limit because it can't help it. It's squeezed from above and it's squeezed from below.